Rates can be expressed using graphs as well. The slope of a graph is often a rate because it compares one value to the other value, remembering that the slope of a graph is how far it goes up for each unit that it goes over. So in this graph, they've given us, this is example 2, page 454, they've given us distance over time. So they basically tell us that in this first little stretch of the scenario, something has gone for 30 minutes, and in that 30 minutes, they have traveled 2 kilometers. Then for the next 10 minutes, up to 40 minutes, they didn't go anywhere because the distance didn't change. And then from 40 minutes to, well, 60 minutes, so in the next 20-minute section here, it went from 2 kilometers up to 5 kilometers. So what we can kind of look at here in terms of the rates is how fast were these guys going each time. Distance over time is speed or velocity, which you guys should remember from, I guess it started in Science 10, but then if you took physics, it's in there again. Anyway, any speed limit sign in the world will tell you what it is. It's kilometers per hour, right? In this case, they give it to us in minutes. We could change that to hours pretty easily if we wanted to. And that's generally how we deal with speed, is kilometers per hour. So that's another fun thing we can play with. So for this first section, we'll go here on the graph. I'm just going to show you which one we're dealing with. We have a vertical change of 2 kilometers. So we will have 2 kilometers over 30 minutes. Now, 30 minutes, I want to change this. So if the minutes is on the bottom and I don't want it, then I put it on the top. And I want hours because kilometers per hour makes a lot more sense. So I know that there are 60 minutes in 1 hour. So I can run these numbers. I can simplify this by going 2 times 60 is 120 over 30, because that's all 30 times 1, it's on the bottom. I've gotten rid of my minutes because they're on the top and bottom, which means my units will be kilometers over hours. 120 divided by 30 gives me 4. So this means that for that part of the graph, he was going 4 kilometers an hour. If you think about it logically, 30 minutes is half of an hour. If he was going 4 kilometers an hour, half of 4 is 2. So it works. So I'm just going to write 4 kilometers per hour along that section of the graph. This one, there is no change. It's flat. Anytime you have a flat line, you have a rate of 0 kilometers per hour. Just make a little hole in my line. So the next section of the graph goes here, and we can see that it changes from 40 to 60 here and from 2 to 5 here. So you can count it, you just go 1, 2, 3, but the technical way to do it would be to subtract them. So I would say that that's 5 minus 2 kilometers on the top over 60 minus 40 minutes on the bottom. 5 minus 2 is 3 kilometers. 60 minus 40 is 20 minutes. It's in minutes, not hours, which makes it difficult to kind of imagine. So we're going to just change it. We'll go 3 kilometers over 20 minutes times minutes on the top, hours on the bottom. That means we'll cancel these because there's 1 on top and 1 on bottom. 60 gives me 180 over 20, which reduces to 90. Minutes are gone, kilometers per hour. So kilometers per hour. That means at this part we've got, sorry, see, I went and checked and looked at my numbers and thought, is that reasonable that this is 4 and that's 90? No, I missed the 0. So I went back and checked it. 180 divided by 20 is 9, not 90. So 9 kilometers an hour, and that fits my data a lot better. Now I've got one more stage that is a little bit dramatic because it goes from here right down to 0 in a little tiny 5-kilometer stretch there. So let's have a look at that one. This one goes from here to here, which is a distance of 5. And I don't even have to go 65 minus 5. I can just recognize that it's halfway across 10, so it's 5. There is a formula, but you don't have to use it. You just have to remember that slope is how much you go up over how much you go over. So however you get those numbers, by counting, by subtracting, by just eyeballing the graph, doesn't matter. So this one says that I went from 5 to 0. It went down 5. Down 5 over 5. Remember that this one's in minutes and this one's in kilometers. So minus 5 or negative 5 divided by 5 is just going to give me negative 1 kilometer per minute. But minutes aren't very helpful, so I'm just going to bring this down here so I can write bigger. And I'm going to write negative 1 kilometer per 1 minute and do my 60 minutes per 1 hour. Minutes cancels out. Negative 1 times 60 gives me negative 60 kilometers per hour. Well, holy cow, that's pretty speedy compared to 4 and 9. But if you look at the slope of the graph, it's much, much steeper, so that makes sense. Now, what we want to, the question that the example was asking us is, could you think of a scenario where this data would fit? So what we want to look at is something's going 4 kilometers an hour, then it stops for a bit, then it goes 9 kilometers an hour, and then it goes back the other way because it's turned around, which is why there's a negative here, at 60 kilometers an hour. Now, this is where I would pause and ask the class, what do you think? But since you're not here, I'm just going to fill you in. I would guess maybe someone is walking and they walk for half an hour at a speed of 4 kilometers an hour. Then they take a little break for 10 minutes because, well, they need to catch their breath. And then they realize, oh no, I'm late. So then they jog to their destination. And maybe something happens. Their mom's like, hey, you're not supposed to be out here. And she picks him up in the car and drives him home. That would make sense to me, that someone's walking and then jogging and then being driven in a vehicle, because I don't know what kind of animal could possibly be chasing you that would cause you to run 60 kilometers an hour. But maybe some of you can do it, not me.